Thank you. Can you hear me? Can everybody hear me okay?
Yep.
Yes? So, first of all, I'd like to thank KVRF for giving us an opportunity to speak here today. By way of introduction, again, my name is Daryl Sartain. I lead AMD's immersive technology development, AR, VR, and our strategies and developments as they apply both to silicon and to our software development within the company. What I hope to be able to go through today is an introduction to how this immersive technologies, this industry, and its evolution into the cloud and into the edge compute is going to affect both from a silicon standpoint, but affect content development and the interplay between silicon development itself, the platforms that are needed, and the ecosystem, the software, the content that rides within that environment. So let me start off by saying that AMD understands what gamers want. Hopefully you as an audience, as an ecosystem, you understand what the gamer community wants. Gamers in general are very intelligent, very intellectual, or technically competent crowd. They focus on things like fast frame rates, low latency, specifically looking for high visual quality. So all of these things drive high compute requirements in silicon, in platforms. But as we go forward, other things like the social aspects, the interactivity, all of these are becoming more and more, have become more and more relevant and key for this community. It's very important to gamers, to most gamers, to be able to share their experiences with their friends. So, there we go. So not only do the gamers have high expectations, but to achieve or to meet those expectations, the platforms have to evolve, have to adapt and enable new technologies. What we've been looking at as a company is for a silicon company, we need to make some very big bets, but more importantly, we have to make some big bets many, many years in advance. For us, a new generation of silicon, new architecture could take between 3 to 5 years to come to market from the time of concept. So what we have, and a lot of what I'll talk about this morning, are some recent announcements, some recent launches that we've had, but how those specific products and product families apply to this industry, to the VR industry, to the cloud and the edge compute capabilities. One of those is 7nm technology, 7nm lithography. And I'll talk a bit about this as I go through, but the 7nm technology enables us to have much faster processors, but also much lower power. And in a given constrained envelope, that's a key element for us. A second, the middle element here is new core architectures, both for our CPU and for our GPUs. So Zen 2 is our newest CPU architecture core, and RDNA, or Radeon DNA, is our latest graphics core architecture. And then the last point that I'll make briefly in the slides here is a new way of building chips, the chiplet architecture. So I want to re-emphasize, though, that all of this background data, as I go through the slides, go through the material, the product development, is intended to give you an idea of the type of planning and development that's necessary from a silicon and from a platform standpoint in order to get to a point where developers, content developers, game developers can actually implement these latest generation experiences. So if I don't know how many people here have seen some of these latest announcements, but I'm going to go through a few just very quickly. We have a recent announcement with Sony for their next generation PlayStation, and that platform is leveraging our newest generation 7nm technology and graphics, Navi graphics architecture. And the Zen 2 core. The Stadia, which is Google's online game streaming solution. So again, the theme here is that we are not looking purely at a game PC. We're looking at technology everywhere within our ecosystem. And Stadia is an example of a cloud-based streaming experience for gaming, where all of the processing is done in the cloud and streamed with very low latency out to the users for an experience that can be essentially anywhere, wherever they happen to be when they want to play. I believe this is expected to launch here in the next month or two. And then Microsoft's Scarlet Project Scarlet, which I'll let you do some online searching, but there's some videos out there that talk about this. It's their next generation console platform, again based on AMD technology, AMD Navi and Ryzen or 7 nanometer Zen 2 architectures. So AMD has become a supplier or is present across the ecosystem. We are in PC gaming, of course. We are in all consoles in the industry today. But as we have developed over time, we moved into cloud. We have a recent announcement with Samsung for mobile graphics processing. We position ourselves, and we have intentionally developed into an entire range of solutions, because gamers aren't a traditional defined category of users. Gamers want to experience or want to have flexibility of playing anywhere at any time, essentially on any platform. And to do that requires a level of capability and interoperability that takes years to develop, and open standards. So I'm going to go through some of the recent CPU and GPU announcements that we made, because what I just introduced a moment ago, which is earlier this year at E3, we announced the latest generation Ryzen and the latest generation Radeon. So the Ryzen family, this is our third generation Ryzen family. It is based on this Zen 2 architecture, 7 nanometer. And the latest generation Radeon, 5700 series. Besides both of those being in the 7 nanometer architecture and we are the first to market in this lithography in the PC industry, PC computer industry. But also, both of these technologies, both of these families, employ the latest PCIe Gen 4. The reason that's important is the bandwidth, the transfer capabilities of that bus is twice as fast, twice as much bandwidth as PCIe Gen 3. With everything that we're looking at in the compute, in the gaming world, and in compute, and as we look towards the cloud and 5G, the amount of computation, the amount of data traffic that's occurring in these systems is growing rapidly. And our goal is to enable and empower you as developers, gamers as users, to not be constrained, to not have limits on their systems. So, very briefly, in the Ryzen family, the 3000 third generation system, this Zen 2 core, again, 7 nanometer, essentially, by moving to this new architecture, we get much faster performance, 15% more performance just on every clock. But also, architecturally, we're getting up to 2x the performance on certain operations like floating point. Sorry, I'm not. There we go. And as an initiative or a strategy rather, as a company, we don't tend to launch new features and new capabilities only in the very high end. Our objective is to launch or to provide new features across a full family. So when we launched this at E3, we were essentially launching an entire family top to bottom. And it's interesting to note, if you think back a few years, well, maybe 10 years now. The first dual core CPU processors came on the market about 10 or 12 years ago, maybe actually a little longer. But now we're looking at desktop processors with 16 distinct cores built in, 32 threads running simultaneously. And if you look at these, we're running them at speeds upwards of in excess of 4 gigabits or 4 gigahertz processing. So tremendous gains in technology and performance. However, that's the CPU. It needs to be balanced by an equivalent capable GPU architecture. And so our Radeon 5700 series was also launched this summer. Again, based on the 7 nanometer family, 7 nanometer lithography. But this new generation of GPUs leverages a new core architecture, and what we refer to as RDNA, or Radeon DNA. That architecture is a new compute core, but also some very streamlined capabilities within the pipeline. We've added features like 4 and 8K hardware decode for video, so those type of operations are fully accelerated in hardware. We've added other features such as DSC, display stream compression for DisplayPort. And these features, if you're not familiar, some of these capabilities are in place primarily because of new display technologies, larger displays, or in some cases because of the evolution of VR. As VR headsets are transitioning to higher resolution and higher frame rate, the only way to achieve that bandwidth, that traffic or throughput, is through some of these new technologies and new capabilities. So, the RDNA, again, some of this I'm going to go quickly, and if you have questions, please ask. But as we look at going to new 7 nanometer architectures, we gain things such as power performance. Within the same power envelope, we can have 50% greater performance, or we can have 50% lower, some percent lower power consumption at the same same performance level. As with the CPU, we have a family of products that came out with this, not just a single high-end product, but each of these, so if you look through the feature set here, again, it highlights some of the new features, some of the new capabilities. And that family is supported by these 3 products initially. Again, all of these are focused on gaming. Now, I'm not going to go through all the details here, by the way, but you're welcome to take a look at that. The key in the GPU world, a key in the GPU world, is to marry properly, to align the capabilities of the graphics engine and the CPU engine so that you have a well-balanced system and you don't end up with specific choke points. But also a goal is to ensure that whatever new features you want to enable, that they're available, they can be enabled here. So from a game development standpoint, we focus a lot of our resources and attention on studio partnerships. Understanding what the studios, what the game developers are trying to do, and how we can either accelerate that or in some cases put silicon in place to enable that. The Fidelity FX is an example. This is a new toolkit. It's not a specific feature, it's actually a toolkit of resources that we are bringing to the market with our graphics engines. The first feature within that is this contrast adaptive sharpening, And yeah, I think you can see on this image. So this is just one example, but if you look at how the work that is done within a game developer, within a render engine, there's a lot of steps, a lot of passes of the render process, and a lot of post-processing steps that are done. What oftentimes happens, depending on the developer and their familiarity with the game engine and so forth, is those post-processing steps can oftentimes take your very, very nice assets, very nice content, and end up essentially smoothing it or losing detail in your content as you're running, your final output. Because each phase, each process step of a given render engine affects the overall content, the overall palette. So what we've done with this contrast adaptive sharpening is, rather than having the user, the developers, have to go through and create their own filters, post-processing filters, we actually have a toolkit where you can essentially turn it on and off, and it will identify areas within the scene that require sharpening while leaving the rest of the scene unaffected. And as a colleague of mine was pointing out, it's hard to see in this still picture, but if you were looking at this or playing this as a game, the difference between these two images when you're actually playing the game is, with the effect turned on, when you can actually see the road and the textures in the road, as you're playing the game, you can actually determine, you can see the slant of the road, and therefore you'll understand how to drive into the slant better, maintain traction, not spin out. So there's some very subtle nuances that come with game developers. And it's unfortunate if you spend a lot of time and resource and energy creating these great textures, and then once you compile them through your post-processing pipe, you end up with a lot of that capability or a lot of that detail lost. So again, this is the type of work that we do, and we do this in collaboration with developers. We spend a lot of our time working with studios, understanding what their needs are, and working directly, through blogs and polls with our user community as well. But again, at the end of the day, the goal here is to bring these capabilities, these features, either directly to the studios, or in some cases directly to the users, where they can employ those capabilities. So, as an example, when we launched this at E3. At E3, we'd already had all of these studios signed up, leveraging this capability in their new content to take advantage of the toolkit, because there's an immediate gain and essentially no overhead for them. They don't have to learn a lot of new things to leverage this. It is a feature, it is a capability and a toolkit that can turn on and off. And that type of development is key as we go into this next generation of immersive technology. I want to make one other quick point here, that same capability. So one of the unfortunate elements of our industry is that when a new technology like this is brought to market, oftentimes it requires inclusion or integration into the games, into the content. And that means everything that exists is left out. Only new content can take advantage of it. To that end, what we've done and what we're looking at as we go forward with our general toolkit features is we've actually given, this is our user control now. So for games that don't have it, for existing games that don't currently have this feature built in, we're giving the users the option of enabling it through software, and if they have the right, newest generation GPUs to enable this. So with existing games, through a very low-level driver instantiation, we now can give them a very similar experience as what we're putting into the toolkit. And then one other, and I'll just kind of go through this very quickly, another example of what's important to the users and to the developers. Anti-lag. Not just latency. Everybody, if you're in the VR world, you're familiar with the term, the need for low latency, because any latency, any lag in your imagery can cause nausea, it can cause you problems with your experience. But even in traditional games, there's a terminology or a need called anti-lag. And anti-lag simply means if I push a button or a key or move something on my joystick, my expectation as a gamer is that the game will instantly respond. Not that it will eventually respond, but instantly. That disconnect oftentimes between users' inputs and those inputs being queued up and eventually getting serviced, those are problems. Those are problems for the gaming community, and so we have within this toolkit, within this feature set, we have something called anti-lag. And it allows us, it provides a means by which we can essentially force and sync the GPU and the CPU so that any user inputs get high priority and immediate servicing through the pipeline. So those are just some examples of the benefits or the type of development that we do as a silicon company, bringing software to the market. Along with that, when we do these types of developments, not only do we work with the studios and with gamers themselves, but it's important to us to collaborate. So we do things like complementary marketing with our studio partners, where we will perhaps have an event, maybe an event like this, or we'll have some press, some PR opportunities where we co-market and put their names out in the press with ours. We also have just development support. So we not only put the toolkits together, but we'll put white papers together, we'll put various training features, capabilities together. And in many cases with things like GPU Open, we will publish these as open standards. Likewise with the Fidelity FX, that's an open toolkit that we're publishing. And then ultimately that comes together as a benefit for all, a benefit for us, for the studios, and for the users, for the game players. Now, trying to get through the product stuff real quick. So, servers. Why is it important for me to be talking about server CPUs at an event like this? Quite simply because the topic of this presentation is cloud and 5G. And what I want to get to, what I will get to here in a moment, is how we are addressing VR and some of the capabilities, the wireless needs and expectations. But servers are also a key element to that. So the server architecture, the EPYC architecture, this is our second generation in our family. We've actually had tremendous success with this, both on performance and in market adoption. Our current generation EPYC, this second generation EPYC, is running in many cases, if you compare this with its equivalent from Intel, the Xeon 8200 series, we're achieving upwards of 2x the performance of Intel's processors today. And I won't go through all the details, I think some of this I've already talked about, but the way that we've achieved that, one of the things that is fundamental, and it goes back to my first slide when I talked about big bets, long-term planning, and trying to make sure we understand the needs of this industry long in advance. With the server, this first generation EPYC architecture contained multiple chips and this Infinity Fabric. The Infinity Fabric essentially allowed us to connect those chips and allow them to communicate with each other and communicate with the I/O on the chip. But as we went to the next generation, to the Zen 2, EPYC, second generation EPYC, we reformatted again. And this time, and you can see there's a different Infinity Fabric, a more inclusive. In fact, this architecture allows all cores to connect to all I/O independently, and it gives us a very, very flexible solution. The reason that, and so the play of this and where this is going to go for us and for this industry, we believe, is this allows for things like virtual machine architectures in a gaming and streaming environment. Not only do we get much greater bandwidth, of course this is again the PCIe interface and so forth, and this is very necessary as we look at a server architecture especially, but as we move this forward in time, we have a performance gain. So all these examples are professional as opposed to gaming, but you can see that the performance gains from this type of an architecture, some of it is simply from speed. But some of this gain is from the Infinity architecture, Infinity Fabric, the chiplet architecture. Having a chiplet design allows us a great deal of flexibility in how we can deploy new silicon or new chips rather, and the core count and so forth. And so we're seeing, in some cases, we're seeing as high as 95% performance gains over the previous generation architecture. And then the EPYC architecture includes a wide range of processors, and at the top you'll see we have a single, what we call a 1C architecture, or 1P architecture with 64 cores, 128 threads, and a single platform. Now, I'm going to move into what I hope is of utmost interest to this audience, which is how do we take wireless VR, how do we take VR and make it interesting to all? How do we bring something that has certain limitations and experience and so forth, and merge it to a best fit for all. So one of the things that we believe is necessary, of course, is wireless. A tethered solution, a cable solution, typically is going to give you the best experience, right? But these all-in-one headsets that are coming out in the market, and there are many of them, these headsets actually have very good specs on the headsets, but their capabilities, their limitations are the processor in the headset, the graphics in the headset. And so our thought, and this goes back several years now when we started developing this, our thought was, how do we take the capability and power of a game platform, desktop platform, or a server deployed platform, and provide that capability directly to these all-in-one headsets. And so the answer to that is, here's an example. This is a demo of, he's playing raw data on the PC in the background. And you can see there's no cables, it's just being broadcast over Wi-Fi. Now I know what you guys are thinking, that guy's pretty handsome with that headset on. So the goal here is, how do you achieve that and achieve it with effectively no latency, no perceived latency? So the answer, without boring everybody half to death, is on the desktop side. And again, this could be any number of architectures. I'll show a server version of this in a moment. But on the desktop side, we have the traditional game engine. You know, your game is running, it's running on a game engine, and rendering out as it normally would. The difference occurs from here, where we run this into our real-time hardware encoder. And from the encoder, we do a network, a Wi-Fi network protocol stack wrapper, and then send it out. Now, I was going to say we require, we don't require, but we strongly recommend AC, 5 gigahertz router, because of the bandwidth. With this setup, running this stream over the 5 gigahertz pipe into the headset, we also developed an app that runs on each of these all-in-one headsets, and there are many of them. I'll show you in a moment. But that app receives the stream, parses it, decodes, performs any local processing, and there are a number of steps that we perform in the headset for masking or hiding latency. So that's where a lot of the knowledge and know-how comes into play with this. And then, of course, it's a full closed loop. So all the movement of the head and the controllers has to be sent back in real time to the PC for updates, for frame updates. So again, we've achieved through this, and we've been demoing this for most of this year, we've achieved through this pipeline, through this process, an experience that most people tell us is equivalent, is no different than a wired experience. We have this running on many different headsets. There are a number of them. We have it running on different development environments, including some of the Oculus development environments. But at the end of the day, our goal, we don't sell this. This is something that is included within our driver stack. And the apps that run on the headset themselves, we provide that for free. Our goal is simply to enable the high performance compute capability, whether it's a desktop or a server, to operate with every platform available and to be in that environment. So, one of the key things I didn't talk about, and you'll see it in the slide in one of the videos here in a second, is why is this, what's interesting and what's unique about this? First of all, I want to be clear that there are several third-party apps on the market that do this type of solution. So we're not the only ones, and we're fully aware of that. A reason why we believe that ours is very, very good, and I would like to say we believe ours is one of the best, is because we architected this solution from the beginning, not as a desktop solution. We architected it as a delivery mechanism, independent. So this solution runs equally well on desktop PCs, gaming systems, on workstation systems, and on cloud or server-based systems. And because it's Wi-Fi, there's no blind spots, and also you're not limited by range. So here's an example. Kelly captured this actually at HTC. these 4 guys are all playing. Now each of them are running their game experience on their own PC, on a separate PC. But all 4 of them are actually being broadcast over the same Wi-Fi. So there's one router in the room broadcasting all 4 simultaneously into each of those headsets. So the beauty of this approach, an attractive solution outcome of this is you're not bound by limits on how many people can be in a space. And that's just with one router, one channel. And then, I'm going to skip that, and then, I'm moving? There we go. Okay, so the last piece here, or close to the last piece, is workstations. Again, we're working very closely with all of the pro market, pro ISVs, and the professional world is very, very interested and very strongly leveraging VR in their markets. So this is an example. Sorry for the noise. This is an example of a virtual production environment where you can have virtual cameras. A producer can actually see multiple viewpoints simultaneously, and all of that again is being broadcasted in his virtual environment in the headset. And then this next video is what I talked a moment ago about. What you'll notice, this guy is actually using the wireless. You'll see he walks around behind this wall. You can see how far away he is from the laptop that's broadcasting this. So the freedom of using Wi-Fi for this connectivity, for this solution is you're essentially as unconstrained as your Wi-Fi signal allows you, which for AC is a very large range, and you're not running into any kind of blind spots with absorption and so forth with your body. Okay, and then the last one is cloud. So we actually developed and ran this demo at Mobile World Congress in February this year. So what you'll see here is we set up a server architecture running 4 GPUs simultaneously, one EPYC CPU, and each GPU, there were 4 virtual instances or instantiations of games running under Windows environment. Each would be broadcast over the 5G network to a unique headset. So what you'll see is one headset running here in this video. And this is actually being broadcast from a virtual machine server setup with the game being live rendered in the server and then broadcast over a 5G emulated network and then into a Wi-Fi to the headset. Again, EPYC and radio. And again, a difference here with the server world is you're talking no longer about pure one-on-one PC setups, but you're looking at a VM or a hypervisor kind of an architecture. So the reason for and a key element of our developments has been that when we set out to do this development, we weren't doing this purely with the idea of PC gaming platforms as our target. We wanted this solution to be fully agnostic to the hardware platform. And AMD's initiatives and AMD's focus towards 5G, towards cloud, is to take advantage of and to leverage these type of developments. And we're pushing this type of architecture, this particular architecture, very heavily into the industry as we go forward. So I think that's everything I had. I appreciate your time today. I hope that this helped and gave you some insights. And if you have any questions, please let me know.
Thank you very much, and we'll be now accepting some questions from the floor. 네, 질문 있으신 분들은 손을 들어주시면 저희가 마이크를 전달해 드리도록 하겠습니다. Well then, the floor tells you. They might be shy, or they might be eager to see the booth outside. Well then, with this, we'll close the keynote speech. Thank you very much.